This lecture is going to cover a number of environmental topics: water, agriculture, soil, and pesticide use. Well, the management of pests. We're going to start with water. So water is something that has been in headlines quite a bit recently. In fact, anytime there's a major drought, generally there's a controversy over who has access to the water and the rollback and restrictions of what water can be used for. This has come into being an issue, especially during the past few years in California, where drought conditions increased severely with every year. Just this past winter, however, they've had a lot of water, so now this drought is going to be decreased, and the concerns with water aren't going to be as pressing. This has also been the central defense of protest at the Dakota pipeline in North Dakota, I think. But the protest is over where this pipeline can run, and it possibly contaminating the water source for drinking for reservations of indigenous people in North Dakota. And then also has been currently in the news with the Flint, Michigan lead levels, which were elevated, and people, government officials knew about it and didn't tell the people. So water is very important, of course, to our society, to our function, to our ability to live. Excuse me. All right, so some things about water you have to understand. Many of these are pretty self-evident, but we'll go over them anyway. So evaporation is the changing of water into a vapor, into a gaseous state. It goes into the atmosphere, where when it cools down, it falls to the earth as rain. Humidity is the amount of water vapor in the air, and we sometimes measure this by relative humidity. And the amount of water that air can hold depends on the temperature. So in very warm temperatures, you can hold a lot more water, which is why generally in warm areas such as the tropics, you have more rain because the air can hold more water, and you have the cycling of water through those events. Condensation then is the changing of water vapor back into its solid form or liquid form. Aerosols are microscopic molecules that provide sites for water vapor to condensate, so bits of dust in the air can cause rain to start. And purification is when water is separated from the minerals, elements, solutes and particles, salts and things which are in the water. So we rely on fresh water, which is one source is groundwater. Other source would be rainwater. But as water hits the ground during precipitation events, some of it runs off or soaks into the ground. When it soaks into the ground, that's called infiltration. Runoff eventually aggregates into streams and rivers, and we call a collection of those in the same area a watershed. Water that is absorbed into the ground, it can be held in the soil and kept static, and that's called capillary water, or plants can absorb it and then it will evaporate into the air through the plants. And some of it then infiltrates further down into the water and into an underwater aquifer, which is our groundwater, and this is what is called the water table. Water then exits these aquifers through openings called springs or seeps, or it just empties into the sea. All right, so the water cycle is basically what we just explained. You have evaporation events causing water vapor to aggregate in the air, precipitation events causing it to fall back to the ground. That water then runs off different surfaces and creates watersheds, and which eventually make it back into the ocean. Some of it, however, goes into the soil itself, is infiltrated. Some of that will percolate then through these aquifers and come out as springs or into the ocean. And some of it will stay in there as capillary water. Okay, and this then is our water table. Alright, so humans have significantly altered the water cycle because we use a lot of water, and we also changed the surface of the earth so water doesn't behave in the same way. We've also changed the earth's climate through CO2 emissions, which increases the temperature, which causes these cycles to occur at a greater rate. So if you have more heat, you'll have more evaporation, you'll have more intense storms. Atmospheric pollution, so we put aerosols into the air, which can affect the production of rain, and also puts elements and other pollutants in the rain, and that's how acid rain forms. We also, of course, need water for our agriculture, for drinking, for other industrial uses as well. And so we use a lot of the water, and then it makes it unavailable for other things. Now, mostly developed countries use their water, use most of their water for industry. The second most consumptive use is agriculture, and the third is domestic, so drinking water. Underdeveloped countries use mostly for agriculture, and then domestic and industry use is about the same. So managing effective use and storage of water is an environmental concern. The ways that we get water or hold it or make it available for use can be multiple ways, but one way is to create a reservoir through a dam. Rather than letting this water go through its rivers and streams to the ocean, you can make a big dam, and that reservoir can hold the water. You can pull from that reservoir and also use the passage of water through the dam to power electric needs. Dams, however, have a lot of consequences ecologically. They basically change the water dynamics of the ecosystem, anything downstream from the dam as well as anything upstream from the dam, because that reservoir or that giant lake wasn't there originally. Groundwater, we can put pumps into the ground when deep enough to where they hit the water table and pull water out that way. Unsustainable use of the groundwater means it will be used up faster than it's replenished. And some aquifers are very, very slow to reform, so you can permanently damage the water table if it's overused. So some of the solutions then is tapping renewable groundwater. So rather than these slow-moving aquifers, you can tap fast-moving aquifers that replenish themselves readily. So use of that water is more sustainable. You can also have desalinization plants where you can get water off of, or pull the salt out of the water. And that's one option because much of our water is salt water. It is more expensive, but it's becoming more affordable. You could use less water. So some of the things which would greatly reduce the amount of water used in agricultural use is drip irrigation. So rather than flooding the whole field, if you just have a little hose with a little bit of water, giving the plants what they need, then you can save a lot of water. Toilets also have been designed to use less water. We can reuse gray water, so water that may be used for washing clothes or dishes, you can reuse that for non-consumptive use. And other agricultural improvements can also reduce water loss. Again, drip irrigation. Some of the key issues with water use then is water efficiency. California seems to be at the center of this and is often talked about when talking about water shortages, water use, because there are so many people there. There's a giant agricultural economy there, and there's a lot of industry there, so a lot of drains on the water in that state. Water subsidies, which cause the use of water to be used more than the cost of it. Okay, so it's best if the cost of water matches the use of water, but with subsidies you reduce the cost and you shift the impact elsewhere. Pollution is always a problem when you are after you use water, you put different things in it, and then what do you do with that water? Well, generally it gets put back into the waterways, and so it creates a lot of problems that way. Watershed management, so looking at not only just one river or stream, but kind of the whole watershed itself and creating a healthy watershed use. Dam regulation, so the use of dams, not over damming watersheds. There have been also a lot of millennial development goals to provide drinking water for areas where water access is reduced, and also doing research and constantly monitoring these water sources to make sure that they can be sustainable and unpolluted. So there are different sources then of pollution. You can have non-point sources where the pollution isn't direct, it's just a function of runoff and all the things which are in these areas then just being dumped in there. And then you have point sources where they are directly just dumping polluted water into streams. Those are different types of water pollution. So fertilizers and farms, they aren't dumping that into the water, but the runoff eventually causes those fertilizers to go into the water source. Whereas if you have a factory, they pump in water, they use it, and then they dump it back into the river. All right, so that's water and some of those issues. We'll talk about solutions and things in class. We're going to talk about agriculture and food to get, or soil and agricultural together, and then we'll end off talking about food. So first, soil is you'd think dirt is dirt, but soil is actually a very dynamic topic. Lots of different types of soil. The proportions of different types of clay, sand, and silt make up these different types of soils. And that's what these soil profiles and classifications are. So some of the properties of soil is larger particles have larger spaces between them, which allow more air. If they're too large, then they won't hold water. But if they're too small, then they will hold the water too well and they won't let any air in between there. So it's better to have a medium size, not too big, not too small. And that's why actually up here, these loams are actually the most fertile soils, allow for nutrients, water, and oxygen to infiltrate the soil and provide the necessary requirements for growth for plants. All right, so this is what soil looks like naturally. You have different horizons. On the top, you have decaying matter. This is called the O horizon. Below that, you have the A horizon, which is called the topsoil. And then you have the E horizon, which is the zone of leaching, where you have kind of water going through here. And then B horizon is the subsoil. And then finally, the C horizon is the parent material. So this is generally rock. And basically, this soil accumulated on top of this parent material over years of succession. All right, so mineral nutrients are required for plant growth, and soils are generally have everything there, but we can supplement them with more fertilizers. The water holding capacity is also very important for plant growth, and the O horizon is what serves to hold in that water, the dead and decaying leaves and plants and other things in there. Aeration is also important. Plants need to breathe, so compaction, making things too dense, is going to prevent the air getting into the soil. And acidity is very important. So depending on what you're growing, you may need the soil to be a little more acidic or a little more basic. And so you can manipulate different or mix in different things with the soil to cause the pH to be what you want. And then salt balance and water uptake also needs to be balanced. All right, so one of the things, again, which is important in healthy natural soils is that the water infiltrates into the soil and is available for plants to, and their roots to pull that water up into their leaves and out their leaves. And that's how nutrients are transported through a plant. If it is too porous, then that infiltration will cause the water to just continue to fall down to the parent material and not be available for the plant. So really, really sandy soils, not a lot can grow on there. If the soil is compacted, then the water won't even infiltrate at all and will just leave the soil as runoff. Now this runoff, if the soil is compacted, can have some devastating impacts, including erosion. Erosion is when the top layers, the humus and the soil particles are taken away by precipitation or wind. Generally, precipitation is the main culprit. But in windy areas where there's not a lot of cover, wind can also do this. There's different types of erosion. Splash erosion is when the raindrops, just the force of that causes the material to break up. There's sheet erosion, where the topsoil is gone and then the fine particles are taken away from the surface. And gully erosion, where you have big divots, which cause, just get bigger and bigger over time. In arid environments, all this erosion can cause desertification, where basically you're creating a desert because the soil can no longer provide the nutrients and water for life. Some of the causes of erosion are cultivation. So if you have too much planting and you aren't diversifying the plants that you're using, then you're going to use up all the soil. The use of fertilizers, non-organic fertilizers, where all they're doing is putting on the minerals and not adding on to the soil, also, just like overcultivation, will lead to the erosion of all the soil. So organic fertilizers are generally better. Overgrazing, if you take all the plants off, those plants are holding the soil together, and so if everything's eating everything too much, then it's not going to work. Deforestation, also forests hold the soil together and are stable. Alright, so one of the things, the most common way to irrigate your fields is through flood irrigation, generally where you just have a canal of water and you flood the little rows of in between your plants, and that's how they get their water. This also causes erosion, and salinization is something that also must be considered. If you're flooding this constantly, every time these evaporate, it will leave a little bit of salt as well, and that can make it infertile. Sediment buildup also with the salt can cause downstream the irregular growth of other plants and animals. So some of the solutions is having a no-till agricultural process, where you're using kill weeds or cross waste to cover the soil, so it just traps the sediments in there. You can have low-till farming, where you only till the soil once to prevent erosion rather than multiple times. Contour strip cropping, so that's what we have here, where you have rather than all the rows going in the same direction, you can have them go perpendicular to each other and cross over each other. That way the sediments will build up in the areas where they cross. Or you can have shelter belts, which are these areas of forest surrounding, or trees surrounding the crops, to again catch those sediments. All right, agricultural. Modern farming involves having lots of infrastructure, machinery, land, fertilizers, irrigation, high yielding varieties of plants to provide all the food necessary for people. The Green Revolution was this effort to increase modern farming in developing countries, and many countries have kind of made the transition then from this primitive style using animals and very hands-on farming to modernizing it through machines and using fertilizers and other things. What this has done has led to really a increase in the efficiency of our use of land, which you can see displayed in this graph. Some areas have not made this transition of the green revolution, including sub-Saharan Africa. Really hasn't made much progress, but all other areas of the world have. All right, one of the problems is farming animals for meat consumption. It's very inefficient. It's actually more efficient just to grow more plants and eat those plants. And 70% of U.S. crop yields go to feeding livestock. Okay, so if you took that 70% and instead fed more people, we would have more and more food than we could eat, possibly eat. Be made way more efficient. We could maybe even divvy up the land differently rather than having it all used for agricultural. There is some problems with having the animals, especially all close together, and that is you can have a lot of diseases such as foot and mouth disease or avian flu. Pollution. So all these animals poop. You got to do something with this poop. And this is the number one pollutant found in U.S. waterways. However, animal farming is very important to subsistence farmers because they don't have many other options. They generally aren't consuming a lot of meat, but those animals are an important source of protein in their diets and other things. All right, so there are a lot of problems with the food and the access we have to the people that need it. So there's different classifications of food problems, essentially. Hunger is a lack of basic food needed to lead a normal, healthy life. So if a country is in hunger, usually it has a famine. They don't have enough food. Malnutrition is the lack of essential nutrients. So sometimes areas have plenty of food, but they just don't have like enough protein or enough calcium or other mineral deficiencies. Undernourishment then is similar to hunger, but more drastic. So it's a lack of adequate food for energy available to sustain life. And overnourishment, which is something that most developed countries, especially the United States, is too much food energy. So obesity is a big problem in the U.S. because we have too much time on our hands and plenty of food to eat. Most undernourished people live in Asia and the South and the Pacific. Undernourishment leads to disease and physical and mental impairment, especially women and children. Main cause is poverty. So this is another reason why there are many different programs, world organizations trying to educate and help these countries come out of poverty. Famine then is a severe shortage of food caused by drought, or sometimes can be caused simply by conflict where the food is no longer being grown because everyone's afraid for their life. And this is a problem for many spots of the earth, many places in the world which were called and have been identified as hunger hotspots. Many of these are found in sub-Saharan Africa. So sometimes just giving food to areas doesn't necessarily solve the problem, because free food is cheaper than buying food. So if a country has the ability to make their own food, that's probably better because it will contribute to their economy. And if you just give them free food, then people will stop buying food, and then you're causing unemployment. Corrupt governments will also make it so that food doesn't get where it needs to be. Usually does help when you are developing an area, helping them come out of poverty, or you have food being purchased within that country, so that way you can still help the local economy and provide food for those who need it. All right, and this can help substantiate the effects and offset the effects of famine. All right, so lastly, pests. All right, so how do we deal with the things that are trying to eat our crops? There's lots of different types of pests. A general definition is animals that interfere with crops, grasses, domestic animals, and structures. So we're more talking about ones that practically cause problems in an economy or society, not necessarily mosquitoes. Mosquitoes, as they are agents of disease, but not just because they buzz in your ear, right? All right, so we have agricultural pests, which are going to cause problems in agricultural efforts. You have weeds that will outcompete or try to compete for with our agricultural products. Herbicides, chemicals that kill plants, and pesticides are chemicals that kill animals and insects. All right, so pest management is an area where these herbicides and pesticides are used. A more sustainable option than traditional methods is called integrated pest management, which uses a variety of different ways, not just chemicals, to control the pests, okay? And allows for long-term management rather than just spraying and killing them all. Chemical treatments are still required in these integrated pest managements, but ecological controls are also used, where you may have a parasite or a predator to the pest introduced to an area to help control it. Now, the reason why chemical treatments have been ineffective is because generally they start to be very effective, but a small group will develop resistance, and then that resistant group will have a population explosion, a resurgence. And then other pests that weren't a problem before because of the reduction in that first pest can also have population explosions, and that's a secondary pest outbreak. And this is usually then tried to be solved by increasing chemical treatments, and it starts this kind of out of control pesticide treadmill. But pest management using integrated pest management is much more effective and much more sustainable. All right, so some of the effects of these herbicides and pesticides can be poisoning. So if you eat a handful of fertilizer, I mean, that's not good for you. You're probably going to die. And that happens occasionally, but probably more prevalent are chronic effects, where small, minute exposure over many, many years can cause a number of health deficiencies such as cancer, dermatitis, birth defects, infertility. And as well, there are some things in the environment called endocrine disruptors which mimic the effects of hormones, and these also, DDT is one of them, are used in, they're originally used to maybe help a cow increase its muscle mass, so more meat can be made. But when they get into the environment, they can cause all sorts of problems for animals and also for humans as we eat and drink water from these areas. Another environmental effect is called biomagnification or bioaccumulation, where you may have a small concentration of this pesticide or herbicide in the water, but it's magnified. So because phytoplankton live longer than algae, and they have to eat many different algae over the life of their lifespan, that very small amount is concentrated, and that happens on each level, to where when you get to these top level carnivores, the things that they're eating have a much higher concentration than at the lower level. All right, so this was a problem with DDT and caused many of these carnivorous birds like bald eagles and osprey to go on the endangered species list, and were very threatened in their existence until we stopped using DDT. Ecological pest control has a number of different aspects to it. You can control it culturally, so through behavioral methods such as cutting and grass, rotating your crops. You can control by natural enemies, so in introducing a parasitoid or a predator. You can use genetics. So one of the things that's recently been used is releasing drone males, so infertile males, into a population, which will decrease. They will go out and try and mate with the females, but they won't produce any eggs, so it decreases the population quite a bit. And natural chemical control, so using hormones maybe to attract them to a certain area, and then eradicating them that way. Again, integrated pest management has been very effective and sustainable in controlling pests. A great example of this was in Indonesia, where overuse of pesticides caused a pest, these plant hoppers, to be resistant to pesticides. So the Indonesian government, in response to that, banned pesticides, educated farmers, and those farmers educated other farmers and showed them how to sustainably plant their crops in a way that reduced pests and created a better sustainable agricultural practice. So the best integrated pest management set action thresholds. They monitor and identify pests. They prevent the pests. They control the pests. And all of this is a large, transparent process in which education is constantly being done, and scientific studies are also being done to be able to effectively manage the pests. Okay, that's it. A lot on many topics, and we'll have a lot to talk about in class.